Let's create a propeller. Save the project name. Define the propeller blade profile. Create a plane with 20 units from the XY front plane. Define the sketch. Create a circle, positioned at 12 and 195. Radius of 190. Then a second circle positioned at 75 and -56. And tangent to the first circle. A vertical line at 0 and with a medium distance of 15. Mirror the second circle. Create a new circle with an internal tangent to the circle and a radius of 6. Select the internal circle. Activate the join function. Identify the circles. Repeat this operation. Delete the circle. Mirror the arcs. And join the straight line. Create two surfaces with splines. The propeller blade will be built between these two surfaces. Define a sketch on the YZ right reference plane, perpendicular to the blade profile plane. Define an open spline with 3 points. Point 1, -3 and 7. Point 2, 1 and 1.5. Point 3, 2.8 and 7.8. Create a plane with 112 units from the YZ right reference plane. Create a new sketch on this plane. And a new open spline with 3 points. Point 1, 4 and 17. Point 2, 1.1 and 0.3.3. -7.7 and 20. Create a linear pattern of curves in the z-axis reference direction, with a total of 2 and a distance of 1.5. Choose Bodies or Curves option. Use the loft feature to create two bounding surfaces. Use the loft function to create the first surface, identify the curves. Repeat the loft feature to create the second surface. Define a boss extrude from face to face. Creating a solid from the first to the second surface. Create fillets in the two edges contours with a radius. The edges fillet are propagated for all edges. Let's lower the plane size. Build a propeller shaft. Create a plane with a distance of 6 parallel to the XY front reference plane. And a new plane parallel to this one with 12. And a sketch and a circle with a radius of 10. And a circle with a radius of 13. Define an upper spline in the YZ right reference plane. For the initial and final points, use quadrant OSNAP function. Define two internal points. Mirror the spline in the 3D environment to create the lower spline. Mirror pattern with the XZ top reference plane. Define a new loft. The profiles are the two circles, and the guides are the two splines. Remember, you can edit features and planes at any time. For example, change the distance of the first plane to 7 and the distance of the second plane to 14. Also change the radii to 9.5 and 12.5. Filter to remove the plane's visualization. The next operation could be performed with a mirror or a circular pattern. Would be safer to use pattern functions if the blade were created as a single body. Let's edit the loft feature and change from boss option to new body option. Now the blade has a simple body. Define a circular pattern. Identify the front face normal as the z-axis reference quantity of 2 and angle of 180. Create a through-hole function with a diameter of 8. Chamfer the edges with 0.5 by 45 degrees. Note that the visualization of some edges is not well defined in shading mode. You can improve the shading quality visualization. Select high or very high quality visualization options, but with some compromise of the model regeneration speed. Let's create the propeller coupling. Create a double center line. And two angular lines of 5 and 85 degrees. And two new circles. Select the lines in sequence to define the contour. Click on the join function to create the first contour. Delete the center lines. We need a total of 4 contours. At this point, the 3 more contours can be created by multiplying the first contour by rotation in the sketch environment, and then creating an extrusion by cutting all contours in one single operation. Or first use the extrusion feature with the first contour, and then in the 3D environment, use the rotation pattern to create the other cut operations. Choose the last option, create the contour extrusion operation. Then click on the rotation pattern feature. Define a total of 4 with an angle of 90 degrees. The propeller is built.